Hello everybody, this is Algebra 2, Lesson 9.5, and it's going to be Part 1 of 9.5. If you want Part 2, Part 3, email me here for that, and email me also for worksheets, online tutoring, and solution PowerPoints. Okay, 9.5, apply the law of sines. Here is our objective here. This is Part 1. We got a 30-point skill sheet that you could get. And we got 12 points of a note-taking guide that you could also attain. Okay, teacher, here is your bell work for your students. Evaluate the expression in both radians and degrees. Solve the equation here for theta. Tan theta equals 4.7. 180 less than theta. Theta less than 270. And yeah, give your students about 5 minutes for this. Okay, welcome back. Here is our solution for number 1. Between negative pi over 2 and pi over 2, it equals a negative 30 degrees here, the inverse of negative 1/2, and then solve the equation for theta. So this is a sketch of where we're at for tan, or the inverse of tan 4.7 equals 78 degrees. So it would be either here or over here. In quadrant 3, it would be 258 degrees added to 180. Okay, 9.5, apply the law of sines. You solve right triangles. You solve triangle right angle. So previously you solved right triangles. To solve a triangle with no right angle, you need to know the length of at least one side and any two other parts of the triangle. The law of sines can be used to solve triangles when two angles and the length of any side are known, angle, angle, side, or angle, side, angle cases, or when the lengths of two sides of an angle opposite one of the two sides are known, side, side, angle. So in those situations you can use law of sines. So law of sines is here. The law of sines can be written either of the following forms for triangle ABC with sides A, B, and C. Sine angle A over A equals sine angle B over B equals sine angle C over C. Or this way, you just reciprocate them, and they all have to be equal to each other. That's the law of sines. So angle 1, solve a triangle for the angle, angle, side, or angle, side, angle situation. We have this triangle here with the above conditions here. So how do we solve this triangle? First, find the angle, 180, so angle A is 48 degrees. It's 48 degrees here. By law of sines now, you plug in everything that you have here. 15 sine over 25. So that'd be sine B, which is here. So 15 over sine 25 would be this one here. So A over sine 48, A over sine 48 equals 15 sine 25. Write two equations, each with one variable, C over sine 107. So equals 15 over sine 25. So A would equal 15 sine 48 over sine 25. And then C would equal 15 sine 107 over sine 25. Okay, so A equals 15 sine 48 over sine 25. So we're going to solve now for these variables. A would be approximately 26.4 in this situation here using your calculator. And then C would be 33.9 for this. So we know this, and then we know this now because of the law of sines. In triangle ABC, A equals 48 degrees. A equals 26.4. 48, 26.4, and C equals 33.9. Okay, now we're going to do one on our own. Students, this is yours. We're going to do this in our guided practice here. So solve triangle ABC. Here's a triangle AB and C. B equals 34, C equals 100, and B equals 8. So this is our situation here, 100. So we can find this, can't we? A equals 46 degrees, so we know that. And then we plug in to our law of sines. A times sine 34 and sine 46 times 8. 8 times sine 46. We're going to cross multiply. Then we get A equals 8 sine 46 over sine 34 equals approximately 10.3. Now we have our second proportion here to handle. We have C over sine 100, 8 over sine 34, 10.3 equals A here. So C sine 34 degrees equals 8 sine 100. So we use our ratio here within a calculator and get 14.1. So here are our measures here. Angle A is 46, side length A is 10.3, and side length C here is 14.1. So that would be our fill-ins there. Fill that in here. There's A, here is side length A, and then side length C would be this here. Okay, SSAK, it's two angles on one side, angle, angle, side, or angle, side, angle. Determine exactly one triangle. Two sides and angle opposite one of the sides. Side, side angle may determine no triangle. One triangle or two triangles. So possible triangles in an SSA case. Consider a triangle which are given A, B, and A. By fixing side B and angle A, you can sketch the possible positions of side A to figure out how many triangles can be formed. In the diagrams below, note that H equals B sine A. A is obtuse and A is acute. So in this situation here, A is less than or equal to B. A is less than or equal to B. We have a situation here where there's no triangle. You cannot form a triangle with that. And when A is acute, so A would be acute here. You get no triangle here either when your height is greater than A. There's no way you can form a triangle from that either. Now, when H equals A, when our height equals A, then you get one triangle in this situation here. A is obtuse and A is acute. So when A is greater than B, you get one triangle. When H is less than A, and A is less than B, you get two triangles here. So this can flip over here for that possibility when H is less than A. And this can hit anywhere here, including over there. When A is acute, when this angle here is acute. And then when A is greater than or equal to B, so when A is greater than or equal to B, you get one triangle here, like an isosceles. Okay, so example 2, solve the SSA case with one solution. Solve triangle ABC with A equals 115, A equals 20, and B equals 11. So we have this situation here where A equals 115, and then A equals 20 and B equals 11 here. First make a sketch. Because A is obtuse, the side opposite A is longer than a given adjacent side. Know that only one triangle can be formed. Use the law of sines to find B. Here is our proportion here using law of sines. Sine B over 11 and sine 115 over 20. So when we have that situation, sine B equals 11 sine 115 over 20. We get approximately 0.49. Multiply each side by 11. And then B would equal 29.9 degrees in this situation here. 29.9. Use inverse function then on that. You then know that C is approximately 35.1. 35.1. Use the law of sines again to find the remaining side length of C of the triangle, to find this side length here. So we set up our proportion again. C over sine 35.1 equals 20 over sine 115. And in that situation, when we do this on our calculator, we get 12.7. And so ABC here are angle measures, and then here is our side length. C here equals 12.7. 35.1, and then C is 12.7. Okay, got to practice here. Solve ABC here. We got A equals 122 and etc. here. 122, A equals 18, B equals 12. We don't know C. We need to find C here. There's exactly one triangle. 18 over sine 122 equals 12 sine B. So sine B would equal 12 sine 122 over 18 equals 0.5654. B would equal 34.40. Now, using that, we got this here. C would equal 180 minus 122 minus 34 degrees would be 23.6 here for C. 180 minus these two angles here gives us 23.6. There's B, and then C is 23.6. So now we can set up our little proportion here to find C, and we get 8.5 for C, the length of C. And that's our triangle right there. 34.4, 23.6, and 8.5. That was part 1. And for part 2 and 3, email me here. Thank you very much.